174. There's a chance there will be a Hess's Law problem there. Okay, 2 carbon solid plus hydrogen gas goes to C2H2 gas. Okay, is that thing balanced? Looks good. Find delta H given C2H2 gas plus 5 halves O2 yes goes to 2CO2 yes plus 2O liquid. Delta H equals negative 1299.6 kilojoules. Carbon solid plus O2 gas CO2 gas okay, and hydrogen plus 1/2 O2 okay. So what's our strategy to solve this problem? What's the goal? What are we trying to do? Yeah?
To take the bottom 3 and make the top reaction.
Exactly. So we're going to twist around the bottom reactions until we can add or subtract them or whatever we have to do in order to get the top one. I suggest just adding. If you add and subtract things, you're going to get messed up. So what should we do with this reaction? Is this good or do we need to change this reaction to get it more like the top one?
Just change it.
Flip it. What do we do here? Okay, so we just flip that one. So we've got 2CO2 plus H2O. C2H2 plus 5 halves O2. Okay. So we're good with that one. What about the second reaction? What should we do to that?
Multiply by 2.
Multiply by 2? Is that a good plan? 2, 2, 2. Make sure to put 2's in front of every single one. What do we do over here?
Multiply by 2.
Okay, what's 393.5 times 2? 780. 781? 787?
That's what I got. 393.5 times.
Yep. 787? Okay. What do we do with the bottom one?
Keep it.
Leave it? We got hydrogen here, we got hydrogen here, we've got 2 carbons, we've got 2 carbons, we got this, we got this. So it looks like we have all of the main things covered in this reaction, right? So let's start crossing some stuff off and see what happens. What do we do with this guy? 2CO2, 2CO2. Gone. What else should we get rid of? Water? We need to get rid of this guy. 1 there, 1 there. Getting close. Oxygen. So we've got 5 halves. And so if you're not very good with fractions, This is 5 oxygens, right? 5 halves times 2 is 5. So we have to get rid of 5. 1, 2, 3, 4, 5. Gone. So we sum this all up. 2CS plus H2 goes to C2H2 gas. All right, great. So we got our reaction that we're looking for, right? No funny business on the coefficients. We didn't multiply this one times anything. So what do we do over here? Just add them. We added everything here, right? We crossed stuff off and then we added, brought it down. We added. So we just add these up. So delta H of the reaction equals 1299.6 plus negative 787 plus negative 285.8 kilojoules. We're good to go. Everyone get that? So Hess's law, it looks daunting, right? There's lots of stuff to do, but we did that whole problem in less than 7 minutes with my sloppy handwriting. So don't get freaked out when you see a lot of stuff on the exam. You know, we had a strategy. We had to get reactants and products, so it was easy to decide to flip a reaction, multiply a reaction by 2 is a piece of cake. This equation told us exactly what to do. And so we just multiplied things out. We did the right things over there, added it up. Fast answer. How else could we solve this problem if we wanted delta H of reaction? Say you didn't have this. Say you had a table. Products minus reactants. Same old story, right? They will give you exactly the same answer. So if you've got a table, you know, I could give you all these reactions. I could give you 10 reactions, and you have to do some crazy Hess's law problem. But if you flip 2 pages in your exam, and you've got all of these guys, what's the delta H formation of this thing? 0. What's the delta H formation of this thing?
0.
What's the delta H formation of this thing? Look it up, right? Well, we just calculated it, but you look it up in the table. So if by chance you had this in the table, 1 step, and you're done. So that's Hess's law, and I will remind you of that, and I will put that on the review sheet. Other questions? Yeah?
With the different types of work, like, I think it's like, in the notes it said like mechanical, electrical, stuff like that.
Yep.
Like, do we just need to know like what they are in their formulas, or like?
Well, I mean, it'd be nice if you knew their formulas, right? Especially pressure-volume work. So if I ask you for a formula for pressure-volume work, that's P times delta V, right? So work equals P delta V. And I gave you electrical, all the other stuff. So the reason that you want to know different forms of work, just like the refrigerator problem, right? You have an electrical outlet going into a refrigerator. What is the refrigerator doing? It's turning electrical work into heat. It's turning W into Q. Are W and Q the same thing? If a refrigerator turns W into Q, you know, it's kind of the same thing, right? How do we know that there's the same thing? They both impact internal energy. You know, it doesn't matter if we put Q in, doesn't matter if we put W in. You guys are very comfortable with Q, right? You kind of can feel Q, so to speak, because it's heat. But W is the same thing. So whether you add 100 kilojoules in heat or you add 100 kilojoules in work, doesn't matter. You've increased the internal energy by 100 kilojoules. There's a hand.
I mean, but they're not really the same thing. I mean, so, like, should we just consider them the same thing within the scope of this class?
Well, so they're 2 different forms of energy, right? Yes. So
different forms of energy.
well, they're different. So they're not exactly the same thing, but they are interchangeable. So whether I do 100 kilojoules of work to something, so I could ask you, let's say, if I add 100 kilojoules of heat to H2 and my delta E equals 100 kilojoules, how much work would I have to do to get same delta E? So if I add 100 kilojoules of heat, my internal energy goes up by 100 kilojoules. If I didn't have any heat and all of a sudden I wanted to do work to accomplish that same internal energy change of 100 kilojoules, how much work do I have to do to it? 100 kilojoules, right? Same thing. So heat and work, you're right. Heat and work are not the same thing, but they're totally interchangeable because of this equation. Yeah?
When is delta E equal to delta H?
Ah, that's a good question. Well, we can go right from this formula. So if, I guess you just have to know this, it's hard to figure it out. So we usually associate delta H with which one of these terms? Q. So if we want to conduct a reaction